Read code question number 1088, confusing number 2. This is hard question. Let's get into it. We can rotate the digit by 108 degrees to form new digit. When 101689 are rotated 108 degrees, they become 01983 respectively. Okay, let's check. 0 convert 0, okay, 1 1, and then 6 rotated 9, correct, and then 8 rotated 8, same, 9 also 6. Okay, when 2 3 4 5 and 7 are rotated 180 degrees, they become invalid because it cannot the number rotated, right? A confusing number is a number that, when rotated 180 degrees, become a difference number with each digit valid. Note that the rotated numbers can be greater than the original number. Given a positive integer n, return a number of confusing numbers between 1 and n incursively. Okay, let's check with example 1. Input is 20, so we need to find out 1 and between 1 and 20. So in this case, 6 is below 20, right? And then 6 converted to 9, and then this one is different. 1 9 6 2 10 1 3 16 91 4 18 81 5 19 61 6. So finally is 6. Okay, next, if the 1 between 1 and 100, it has the 19 value. Okay, how we gonna do? Okay, I think that there are two types of the hard question. The first is the question, but it is really harder than normal question, and the second is that is hard, but that is combined two normal question. I think that this one is the second one, and even hard, that is the combined two normal difficulty question. So at this time, okay, I gonna use the recursion because we need to make the all of permutation. And then second, while I counting, I will check the different. And then at that time, I will make the another function to check that is confusing number or not. So that is confusing number, and then that is within n. I will count number to 1. Okay, let's start implement now. First, we needed to make the number, the material, the converting to generate all of the rotated number. So to converting, we need the map. So self convert and 0 0 and 1 1 and 6 change it to 9, and then 8 to 8. And last 9 to 6, and then we need one more global variable is counter. Counter is start with 0, and then I will do DFS, and that start is 0 because I would like to use the first digit. Start with the first digit and then return self counter. That's all. So, and then I need to make DFS first, and then this is first current. And okay, let's make the base case first. If current is larger than n, return, because we check only the below equal n, right? So next is I will make the permutation, the rotated number from 0. Okay, so to do that, we needed to use iteration. So for next in self convert, if we're getting the map, at that time we able to get only key. So this is we looking for, right? 0, 1, 6, 5, 8, 9. And then next we need to combine to current. At that time, current number I will shift to 1 left. To do that, I will current multiply 10, then is the shift, and then our first digit it will locate the next. For example, if current is which number is good? Okay, now current is 6, and then we received with the 8, and at that time current multiply 10 plus next is, okay, let's say next is 8. 8 is, that means this is 68, right? That is what I'm looking for. We shift the current to left side and then add the first digit is next. Okay, then let's check. We needed to check the counter between 1 to 0. So if this one 0, we did not count it, excluded it. So if next is 0, I will continue. Did not check, and then now self count at first. Next must be smaller or equal than n, and easy difference. Next number is easy difference. That means if rotated, the value must be changed, right? And then we make recursion relationship next to make the next digit. So while using recursion, maybe a digit will be increased 1 by 1. Okay, all right. Then let's make this different, and then receive nums, and this next is better. Okay, good. Next, this next. So when I list the next new number, and I needed to keep the original to check with converted, the initial value 0, and then while next, and then after finish each iteration, I will decrease index. So converted to convert current converted value, left shift, and then add self convert, and only the first number. First is next 10%, 10, and then add it to converted, and then okay, finally we check when you finish converted original. If this one is different, is converted, we will return true. Okay, let me fix the typo. Okay, looks good. Okay, here occur. Wow, it is too big. So okay, let's make it fast. Okay, now we used backtracking, right? So but okay, let me think a little bit deeply. How about that? In this case, even though this is the valid, but this one multiply 10 is invalid, next operation is no need. So what if we add current here? That means any number is if after this one, any number must add the next, right? Because this is minimum. So if this number did not pass it, that means no need to this operation, right? So I will do this one. Make sense? Okay, 27. Okay, thank you.